The two major ideas we have talked about so far are discretization and linearization. Let's put them together. So here's an overview of the two together. We talked about discretization before, and here was the overview of the discretization. And the end point of the discretization is a set of algebraic equations relating neighboring cell center values. And we derived that from the integral form of the governing equations by doing control volume balances cell by cell. And in the process of going from the integral form to the set of algebraic equations, we introduce an error called the discretization error. And I did indicate the error as we were deriving the algebraic equation for the mass balance for our particular cell. We can reduce the discretization error by using more cells in the domain, so that's mesh refinement, or we could decrease it by increasing the order of accuracy of the interpolation. And we will see that a little bit later. The algebraic equations that we have are nonlinear, so we have to linearize them about a guess value. And when we go from the nonlinear set of algebraic equations to a linearized algebraic equations relating cell center values, we introduce another error called the linearization error. And these two errors are different. And to decrease the linearization error, what we have to do is solve iteratively, and after each iteration we update the guess. And we stop iterating when our imbalances of mass and momentum are below some selected tolerance. If we had the exact solution to the nonlinear algebraic equations, the imbalances of mass and momentum would be zero. But since we have a linearization error, it's never going to be zero. But if it's below a tolerance, then our linearization error would be acceptable. Now, so this, I've seen this confusing students because they think, oh, if I refine the mesh, my error should go down. And what happens is, the iterations become actually harder to converge when you refine the mesh. So your discretization error has gone down, but your linearization error has ballooned. So these are two entities that you have to balance, and sometimes it becomes like you reduce the discretization error and your linearization error kind of goes up. And so we will come back to this and see this when we are doing our CFD case studies in Fluent. But before that, so I want to talk about when to stop iterations, and that's an important consideration for the code user in CFD. So let's take a look at that.